Welcome back to Refreshing Careers. Today's topic is linear programming. We're going to do the part 3 of it, and we're going to cover a question today. Operations research for MBA. This is the subject. Operations research is the subject. Now let's go to the question directly. A Limited produces two types of models, P and Q, by using machines M and N. 1 unit of P requires 1 hour at machine M and 3 hours at machine N. And 1 unit of Q requires 2 hours each at machine M and N. Each unit of P yields a profit of rupees 50, while each unit of Q earns a profit of rupees 60. Number of hours available per week on machines M and N are 40 and 60 hours. How many units are required if each product should be manufactured so as to maximize profits? Formulate LLP, LPP and solve. Okay. Let me explain the question. What they're saying is there's A Limited. A Limited produces two types of models. So it's basically producing model P and model Q. So its products are P and Q. P and Q are the products. To produce P and Q, they require two machines, and the name of the machines are M and N. So these two machines are required to produce P and Q. 1 unit of P requires 1 hour at machine M and 3 hours at machine N. To produce 1 unit of P, you have to spend 1 hour at machine M and you have to spend 3 hours at machine N. So if I want to produce 1 unit of P, I will have to go to machine M and spend 1 hour. Then I'll have to go to machine N and spend 3 hours. Now, if I have to produce Q, I'll have to spend 2 hours each. That means if I want to produce product Q or the model Q, I will have to spend 2 hours at machine M and I will have to spend 2 hours at machine N. So I would have to spend 2 hours each at machine M and machine N. Each unit of P yields a profit of rupees 50. If I am producing P, per unit I am going to get a profit of 50. That means if I produce 2 units, I get a profit of 100. 3 units, 150. 4 units, 200. So that's what they're saying. For per unit, we'll get a profit of rupees 50. Then they're saying for Q, similarly for Q, we'll get a profit of 60. For model Q, how many ever you produce? Like if you produce 1 unit, you get 60. If you produce 2 units, you get 120. So for Q, per unit profit is 60 rupees. So per unit profit of P is 50, per unit of profit of Q is 60. Number of hours available per week on machine M and N are 40 and 60 hours. Now we can't use this machine continuously. There's a restriction put. Machine M can be used only for 40 hours in 1 week, and machine N can be used only for 60 hours in 1 week. So this is a restriction. Every restriction becomes a constraint. See, because if this restriction was not there, then there would have been no time constraint. Like if they would have not told that only 40 hours you should spend at machine M, only 60 hours you have to spend at machine N. If this constraint was not there, I would have spent 200 hours, 300 hours, and I can just keep producing as much as I want. But there's a constraint here. So whenever we are taking decision, we have to keep this constraint, these two constraints in mind, and then take a decision. Like when I'm taking a decision to produce, let's say 50 units of P and 40 units of Q. So I'm taking this decision should also involve, I should take this decision after considering this constraint. These constraints should also be considered before I take any decision. How much of P to produce, how much of Q to be produced, that can be decided after considering these facts. So constraints are very important. That's why you write the word subject to. You have seen, you always write as this is an objective function subject to certain equations. That's subject to other restrictions, other constraints. So you're doing something subject to some other things. Okay, like I can produce 100 dolls subject to the fact that the cotton availability is only this much grams or these many kgs. So that is a restriction that is put. So I should keep that restriction in mind, and only then I should go for producing 100 dolls. If I don't have enough cotton, then there's no point of producing so many dollars. I can't produce. So I have to, whenever I'm setting a goal, it has to be subject to the constraints. And the constraint in this case is 40 hours and 60 hours. 40 hours at machine M, 60 hours at machine N. And then they're saying how many units are required. They're asking how many units are required if each product should be manufactured so as to maximize profits. So they're asking how much of P should be produced, how much of Q should be produced so that you can maximize your profit. So your aim here is to maximize profit. And how do you maximize profits? By producing the optimal quantities or optimal combination of P and Q. By producing the correct quantities of P, not correct, optimal word is better. By producing the optimum quantities of P and Q, you will be maximizing the profits. So you need to formulate an LPP and solve. So your first objective function is, what's the objective? Objective is to maximize profit. Okay, the objective of A Limited is to maximize profit. How do I know? It's given here. Okay, they are saying that each product should be manufactured so as to maximize profits. That's why I know that the objective of A Limited is to maximize profits. What is the profit? We don't know. Profit is not being given. So we don't know the profit. So let us assume the total profits of A Limited is Y. This Y can be X, Z, anything. Usually people use this as Z also. Anything is fine. You can use it as Y, Z, X, anything. You just write it down as, you write this assumption that what does this Y what it refers to. So let's assume that, okay, I'll come to this later. Now what is total profits? Total profits is Y, right? A total profit is nothing but, it is a summation of two things. That is profit from model P plus profit from model Q. Total profit of A Limited will be the profit that you're going to get from model P plus the profit that you will make out of model Q. So when you add profits that you're going to make from model P and profit that you're going to make from model Q, then you'll get the total profits. Now what is the profit from model P? Profit from model P is total units of P into price per unit of P. Profit from model Q is total units of Q into price per unit of Q. Now what is the price per unit of P? Price per unit of Q, this is easy because it's given in the question. Price per unit of P is 50, price per unit of Q is 60. So 50 and 60 we know. We know that price per unit of P is 50. That's why 50 here. We know that price per unit of Q is 60. That's why there's a 60 here. We know that total profits is Y. Now what is total units of P? This is what we need to find out. So we are going to replace this with X1. Total units of model P will be represented by X1. So this will be X1. That's why X1 into 50 plus total units of Q. Total units of Q will be represented by X2. So when you replace all these things with X1, X2 and the per unit profits of P and Q, then the linear equation that is formed is Y is equal to X1 into 50 plus X2 into 60. That is total profits is equal to X1, which is the total units of model P, into 50. That is the price per unit of P, plus X2, which is the total units of model Q, into 60, which is the price per unit of P. This X1 and this X2 are called as decision variables, because see, our aim is what? Our aim is to maximize profits. And how do you maximize profits? See, this is the formula of profit, right? So the total profit is equal to all these things. This is what we found. This is what we did. That's how we arrived at this equation, right? So your profit is equal to X1 into 50 plus X2 into 60. Now, if you would remember, there's an assumption in LPP which I had explained in the first part of this series, in which I told that there are some 5 to 6 assumptions which I explained. One of the assumptions was constant price. That is this 50 and 60 price per unit. The price per unit of input and the price per unit of output is going to remain constant, and that cannot be changed. Is an assumption in LPP. That is an assumption in LPP. So there's no way that you can change 50, and there's no way that you can change 60, because you're assuming that price will be constant. In every LPB problem, assuming that the price will be constant. So you can't make this 50, 80, because you see you can increase profit in two ways, right? By either increasing the quantity or by increasing the price. If you increase the quantity also, your profit will increase. If you increase the price also, your profit will increase. But in this case, since there's an assumption that whatever happens, your price is going to remain constant no matter what. So you can't play around with the price, but you can play around with the quantities. You can change the quantities. So price 50 and 60 you can't do anything, but what you can do is you can change the quantities. That's why x1, x2, that is the quantities of P and Q, would be the decision variables, because these decision variables x1 and x2 can help you achieve your objective of maximizing profits. This x1 and x2 are decision variables because they help you take the main decision that will help you achieve the objective of maximizing profits. Okay, now next is constraints. Constraints is easy. Let me just show what the constraint is. The constraint is this: 40 and 60 hours. Number of hours available per week on machine M, and machine M is 40 and 60 hours. So okay, for machine M, so in machine M the total hours available is, in case of machine M, total hour available is 40 hours. 40 hours is available. In case of machine N, total hours available is 60 hours in a week. So in 1 week, machine M can be used only for 40 hours. Machine N can be used for 60 hours. That is, maximum 40 hours you can use in a week, and maximum 60 hours you can use machine N in a week. So now we have to form the equation for constraint. Okay, let's do this. So first, with respect to machine M, first we'll be doing with respect to machine M. Okay, now P requires 1 hour at machine M, Q requires 2 hours at machine M. It's given here, P requires 1 hour at machine M and Q requires 2 hours at machine M. So 1 hour and 2 hours. Okay. So 1x1 plus 2x2 will be less than or equal to 40. Okay, the next thing which is given is 1 unit of P requires 3 hours at machine N, and 1 unit of Q requires 2 hours at machine N. Okay, 3 hours and 2 hours at machine N. So with respect to N, we are going to write down now 3 hours and 2 hours. So 3x1 plus 2x2 will be less than or equal to 60. This is the equation. I'll explain how this came again. 1 is nothing but 1 hour. 1 hour is required to produce 1 unit of P. 1 unit of P require 1 hour. But we don't know how many units of P we are going to produce. So we assume that number of units of P is x1. So to produce x1 units of P, we require x1 into 1 hour. Okay, similarly, we require 2 hours. We require 2 hours to produce 1 unit of Q at machine M. Okay, this is at machine M. This also is at machine M. So at machine M, to produce Q, we require 2 hours. Per unit of Q, we require 2 hours at machine M. So 2 hours is for 1 unit. And the total units of machine M that we are producing is x2, which is what we have assumed here. Total units that we are producing of Q is x2. So 2 hours into x2, less than or equal to 40. Why less than or equal to km? Because they have told that maximum you can produce 40. You can either produce anything, that is the total has to be equal to 40 hours. The total hours, see, 1x1 plus 2x2 is your total hours at machine M. 1x1 plus 2x2 is your total hours at machine M, and this total hours at machine M, we don't know what it is. But all that we know is that whatever it is, it has to be either equal to 40 or it has to be less than 40. It cannot be more than 40. That's why there is less than symbol and there is equal to symbol. I hope it's clear. Then again this, we require 3 hours. We require 3 hours to produce. We require, it's given here, we require 3 hours to produce 1 unit of P. We require 3 hours is required to produce 1 unit of P. Okay, that's why 3 came here. We require 3 hours to produce 1 unit. And there are how many units of P? There are x1 units of P. We don't know the number of total units of P. So 3, that is number of hours required to produce 1 unit of P at machine N into number of units that we are going to produce of P will be, this will give you the total time required at machine M to produce P. Now we have to similarly find out total time required to produce Q at machine N. To produce 1 unit you require 2 hours. So there are totally x2 units, so we require 2 into x2. So we require 2 x2 hours at machine N to produce Q. So the total hours required at machine N, okay, to produce P and Q. So total hours that required is 3x1 plus 2x2. 3x1 plus 2x2 is the total hours that you would require at machine N. And the constraint is that this total hours required at machine N will either be equal to 60, or it will be less than 60. What they have told is it cannot be greater than 60. What they have told is it cannot be greater than 60. So it has to be either equal to 60. So the total has to be either equal to 60 or it has to be less than 60. Okay. This is the less than symbol. This is the greater than symbol. Okay. This is the less than symbol and this is the greater than symbol. So this is what I've used here. Less than symbol. This total has to be either less than or equal to 60. That's how the constraint have come here. Now the next slide. This is very easy. Non-negativity condition. Non-negativity condition just says that the decision variables are not going to be negative. Okay, it's not going to be negative. It can be positive. It can be 0. Yes, but it cannot be negative. It cannot be negative. Okay, it cannot be negative. It can be positive, it can be 0, but it cannot be negative. What can't be negative? Your decision variables cannot be negative. And what are the decision variables? Your decision variables are this, x1 and x2. That cannot be negative. Okay, so you can write this as x1 has to be greater than or equal to 0. x2 has to be greater than or equal to 0. This is nothing but they are indirectly saying that this can't be negative. x1 has to be equal to 0, that is this, or x1 has to be greater than 0, that is positive. It cannot be the other way around. Same thing is happening here. They are saying that x2 has to be either equal to 0 or it has to be greater than 0. That's why this is a non-negative condition. Another way in which you can understand why they are saying this is, see, here x1 and x2 represents total units of model P, total units of model Q. Now, can that be negative? Okay, number of units produced of P can be 0. That is no production. It can be 1, 2, 3. It can be any positive number. But can it be a negative number? Can you produce minus 5 pence? That's not possible, right? That's why production is always going to be positive. You're producing something, so either it will be no production or it will be a positive production. That's why this cannot be negative. That's why decision variables cannot be negative. That's why there is this constraint, this condition called as non-negativity condition, which says that your decision variables won't be negative. That is, it will be greater than or equal to 0. That's what is being written in this form. This is a greater than symbol, equal to symbol. Okay, now the problem can be written as. Now we solve the entire problem. Let us just write it down. The first thing which we did was here. Y is equal to your profit. Y is equal to x1 into 50 plus x2 into 60. Y is equal to x1. Y is equal to x1 into 50 plus x2 into 60. x1 into 50 plus x2 into 60. Subject to certain restriction, constraints, whatever you want to call it. The constraints are x1. 1x1 can be written as x1. So x1 plus 2x2, x1 plus 2x2, x1 plus 2x2 less than equal to 40, less than equal to 40. 3x1 plus 2x2 less than equal to 60. 3x1 plus 2x2 less than or equal to 60. And the next thing is your non-negativity condition, that is this: x1 greater than or equal to 0, x1 greater than or equal to 0, x2 greater than or equal to 0. This I just summarized the problem. This is your objective function, these two are constraints, and this is your non-negativity condition. And one more thing I'd want to add: this constraints can be called as regular constraints or inequality constraints. Do not get confused with it. Constraints can also be called as regular constraints or inequality constraints. If you are seeing a new term, there's nothing to get confused. It means the same. Please do like and subscribe the video. Thank you.